All right, let's do a little example. Let's look at this video. This video is called Comic Strip, and it's about this little boy that's invited to this birthday party. And he receives this map in the mail. And I'll show a picture here of the map, but you can watch this clip. You're just going to watch a little bit of it. You can watch it from, let's see, the clip should pick up about 1 minute. So you watch it about from 1 minute, oh, until about, I don't know, 2:20 or so. Um, and you can watch it now, right here. It's kind of a fun clip, but really the point of this is just to look at the map. And so um, we have the map, and it shows the directions to get to the little girl's house. And I want to draw out a vector diagram. Now, notice that I have several vectors that I can draw here. Uh, I'll draw it out in more detail. But I have vectors that go in these directions. And then I want to figure out what is the sum of all those vectors, or what is the magnitude of the displacement, the magnitude and direction of the displacement. That is, I want to know what is the magnitude and direction of this vector, right, which is the sum of all of those vectors. So let's see. My vector diagram might look something like this, and I'll just give some estimates for the distances. So I have 5 meters to the south, so that's going to be negative 5 meters because it's to the south. Then I have 20 meters east, so that'll be plus 20 meters, and it's positive because it's to the east. Then I have negative 20 meters to the south, so negative 20 meters. It's negative because it's to the south. 10 meters to the east. So of course it's positive because it's to the east. And then just 5 meters to the north. Walking into the little girl's house. Alright, now I want to create a table of the x and y components, or find the x and y components of all of these vectors. I like doing it in a table form because it's all laid out very nicely. So here's the vector on this side. I have our 5, 20, 20, 10, and 5 meters. And then I can write out what are my x and y components. Now, on the 5 meters to the south, the x component is 0, and the y component is negative 5. 20 meters to the east, it's going to be plus 20 and 0. 20 meters to the south will be 0 and negative 20. 10 meters to the east will be plus 10 and 0. And then 5 meters to the north will be 0 and plus 5. Now, I want to know what is the sum of all of these x components. So this is going to give me the vector r, which is going to be the sum of all 5 of these vectors. That's going to be a plus b plus c plus d plus e, the sum of all 5 of those vectors. In order to find the x and y components of those vectors, I just add up the x and y the x components of a, b, c, d, and e, and then the y components of a, b, c, d, and e. So I get an x component of 30, and a y component of, looks like, negative 20. If I go back to my figure, or let's see, right here, I can sketch in, what is my vector is going from here to here. And now I'm saying that the x component is here, and the y component is here. So I'm saying that the x component is 30, this value is 30, and that this value is negative 20. So those are my x and y components, and that seems to jive with just this little sketch that I've made of these vectors. So now I have the x and y components. I want to find the magnitude of the displacement. See if I have this on the next page. I can find the magnitude of the displacement, r, is going to equal the square root of 30 squared plus negative 20 squared. So that's going to be equal to 36 meters. Or keeping proper sig figs, I would express it as 40 meters. So that is the magnitude of the little boy's displacement when he goes from one place to the next. And then the angle theta, now remember, this is the vectors that I have. These are my x and y components. This is my vector. I want to know this angle theta. I know this is 30. This is 20. That angle theta is going to be the inverse tan of the opposite over adjacent. That's 20 over 30. Notice how I've left the signs off. So that's going to be 34 degrees. Be very careful on how you put this in your calculator. All of your calculators are a little bit different, so you'll need to practice that on your own. However, that's not the entire answer, 34 degrees. I also need to add a qualifier where this is measured from. So I can express this in several different ways. I can say 34 degrees below the positive x-axis. I can say negative 34 degrees from the positive x-axis. The negative representing that it's below the positive x. I can also, instead of giving the angle theta, I can instead give this angle, which is going to be, is that 360 minus 34, which is 326, 326 degrees from the plus x-axis. All right, so there are a variety of ways that you can represent this. But it's very important that you actually get the appropriate direction. We'll stop there and pick up with projectile motion next time.